different forms. You will have all of these viewers, if you like, for different file formats embedded in an IDE. IDEs typically provide intelligent code completion, so they will understand what you're writing, and even before you finish writing your code, they will offer a set of available options, which are either syntactically correct or logically correct, and you'll be able to select. We also call this feature sometimes tab completion, because if you press a tab key, it will offer you a set of possible options to carry on with. They will also offer you powerful search. So if your code base grows, you might need to do loads of searching. So it will search throughout your software project. It will also search through the documentation, which might be available within an IDE. So you can have embedded documentation for the libraries that form the core of your programming language, as well as external or third-party libraries that you import for your code to work. And you can do reference lookup. Often you'll be able to look in the source code of these libraries as well, if that's how your IDE is set up and if that's available for the libraries that you're third-party libraries that you're using. So you can actually have really deep inside the libraries that you're using. IDEs will also typically have integrated testing frameworks, making it easy to or easier to run loads of tests across your whole code base in an automated fashion. Some of IDEs offer integration with version control systems, so you will have a graphical interface to interact with your version control system, for example, Git. So you wouldn't have to do it via a command line, and you will have some graphical aids to help you understand what's going on in your version control. You will have debugging tools typically available for you, which is something that we will work on today. So quite advanced tools to help you inspect your code and pause your code as you're exploring and finding and detecting bugs. IDEs also have integrated terminal for executing commands. So if you prefer to run your commands from a command line, you can do that as well within the IDE. So you don't have to use graphical interface if you don't want to, but you often can run your code from a graphical interface. There would be loads of buttons to click on, which will either start the execution, compilation, or testing or debugging of your code. And finally, they will typically all offer Project Explorer, so you will be able to look and navigate through your files that are in your software project, and you will be able to manage your software project more easily. Okay, so that's quite a lot of features. Just want to briefly take you down the memory lane, what it looked like before we had all of these modern IDEs. And you probably don't remember this. I think even I would struggle to remember what it was. I think I always had some kind of an idea available to myself. But it is possible, and it was possible, and people have been doing this for years to actually develop code just by using text editors, which is what predated modern IDEs. So you would have a text editor, which is normally terminal or command line based. You would start it from a terminal, you would type your code, you will then exit your editor, and then within the same terminal, you would try to compile or run or execute your code. And then there would be an error, and then you would open the terminal again, and the text editor again, and then you will repeat that process. And it was much slower, and typically there was no syntax highlighting back in the early days. Now these text editors, even if they are command line or terminal based, are very advanced actually. So they're almost like modern IDEs. You also had to interact separately with all the other tools of the software development ecosystem. So you would have to switch between the code editing, the compiling of the code, the debugging of the code, the file system where your files are located, and so on. So it was a much more fragmented experience. So I think have a look back at the features of the IDEs, it leads itself to why should we use IDEs. So they help us reduce setup and development time. We don't have to switch between many different tools. We don't have to use command line text editors unless we want to and prefer to do that. So everything you need to read and edit and run and debug code is available to you in one place. So the development time is reduced. Think about saving 5 seconds or a couple of seconds every time you have to switch between tools. And then this time adds up over a course of a year, for example. So they offer helpful tools like syntax checking, code suggestions, auto completion for code, error checking as well as you type your code. So that all leads to fewer errors because you get some real-time feedback and intelligent suggestions as you're typing your code. So less time needs to be spent debugging and fixing errors. They also help with the debugging and testing because you've got these tools that can pause execution of your code. You can inspect the values of and state of your code at a particular point in time and so on. And finally, they provide a consistent environment across projects. So you might be involved in multiple projects, but if you use the same IDE, then it all looks very consistent and it's easy to switch between different projects because you're familiar with an IDE. Even if you have to switch between different IDEs, they're all fairly similar and have a similar set of features. So even if you learn one IDE, there is loads of knowledge that can be transferred to another IDE if you have to switch. Couple of popular IDEs. It might be a matter of choice. We will be using Visual Studio Code for this particular session. It's used often by researchers who code. It's relatively lightweight but highly customizable because you can install loads of plugins and add-on, and it can support multiple programming languages. PyCharm is another one which is used for Python development. There is RStudio as well, which is used for R programming, but can also support other programming languages. And also it allows users to mix textual files written in R Markdown. So you can mix your text with your code, and then you can use this as a form of a lab notebook, which is similar to Jupyter notebooks for Python. Eclipse is often used for Java and other compiled languages if you're using those. Jupyter Lab, which is another interactive environment for Python, often used for data science and slightly advanced version of a Jupyter notebook. Spider is also one that is used and is popular among scientists who are using Python. So code debugging is one of the things that IDEs are really good at, and this is the one that we are going to be exploring as part of the practical activity. What do we mean by code debugging? It means finding, detecting errors in our code, understanding why these errors are happening, and then fixing these errors in our code. Multiple debugging techniques exist. One of the, I should say, popular ones is rubber duck debugging. I don't know if you've heard about that one, but that's talking to a rubber duck and explaining, or a colleague, if you don't have a rubber duck. Talking to a colleague also helps. You explain to your colleague what the code does, and you're having some error or some problem. And as a part of the process of explaining, you actually realize where your error is. You can add print statements to your code at certain locations to inspect the state of your code, or you can use assert statements in the similar fashion to see whether certain conditions are true or false at certain locations or positions in your code. You can use more advanced tools for logging. Basically, underneath, they're doing some print statements for you, but they're a bit more advanced than that. You can use a built-in debugger, which is what we're going to cover today. And you can also write tests. By writing tests, you cover and check your code base, and you kind of anticipate the errors that you might have. And that also helps with debugging by actually reducing the amount of debugging that you have to do, which is another bite-sized RSE topic that you might come to. Okay, so with that, we are going into the practical activity, and I'm going to hand over to Steve to take you through this live demonstration / live coding session.
Okay, thank you very much for that great introduction, Alex. So what I'm going to do is I'm just going to share my screen, unsurprisingly. So I'm going to bring up a couple of slides, talk for a little bit, and then we'll go right into the practical. So I'm just going to sort out a few things I need to make sure I've got on my screen just before we proceed. Okay, right. So what we're going to do in the practical activity. So can everyone see that okay? The slides, is that coming through clearly? Okay, brilliant. Good, good. Right, so we're going to look at using Microsoft Visual Studio Code to help see how I can help you write, run, and also, as Alexa said, debug code as well. So I'm going to be demonstrating this via live coding. So I'm going to be sharing my screen, going to be presenting a demonstration, and you're free to follow along with follow along with me if you wish to do so. You don't have to do so. As you said, you'll need VS Code already installed. And in order to run any example programs in VS Code, you're going to need an existing Python 3.8 or above installation. We're also going to be providing an existing code repository for you to use for the activity that contains the code that we're going to be playing with throughout. So just as a starter for 10, I'm going to ask a quick question, and I'd like you to do a reaction on Zoom. So the question is, how many are intending to participate in the live coding activity? So if you are going to be participating, could you do a green tick box? If you click on React, you should see there's a green like tick box thingy. And if you're not planning to do so, which is absolutely fine, just put a red X instead, just to give us an idea of numbers, and then I can use that as a guideline just to check progress later on. Okay, I'll give you a second to find all that out. Maybe your first time using Zoom reactions, so yeah, it can be a little bewildering to find all the right clicky icons, but you should find the React or reactions down the bottom in the main Zoom window there. Okay, right. So it looks like we have perhaps around about 8, 9, possibly around 10 or 11 maybe people doing the practical. That sounds great. Okay, so I should also note that the live coding activity is only a taster. There's always obviously more to learn. You know, I'm always learning new things, even though, you know, I'm going to be teaching this to you today. I'm still learning stuff about Microsoft Visual Studio Code every time I use it. There's always something else I find out that's a handy thing to know. It's a lifelong journey. Now, Alex has already provided a Google Doc for you to sign in, but it also includes links to other further information and guides on things we'll cover, and also for learning more about the topic as well. So hopefully there's a few links there that will be of use to you. As Alex has said, unfortunately, due to the time constraints, we'll be unlikely to be able to solve any in-depth technical issues you may have. But if you do run into any issues, hopefully, even as a demonstration, it'll still give you a taster of how IDEs can help when developing code. So what are we going to cover specifically in the activity? So firstly, we're going to run VS Code, unsurprisingly, and we're going to do a little bit of configuration to start with. So we're going to be using Python to illustrate what IDEs can do for us. And Python VS Code can support many, many different languages. And as part of that, we're going to be installing some extensions to VS Code, which is thankfully a straightforward process that'll help us with our experience of writing Python using the IDE. And there's many hundreds of other extensions available for VS Code, many for Python, many for other languages that you may decide to use. So if you ever come across wanting a feature in the IDE that you don't think exists, I would probably wager it's pretty certain you're going to find some feature or something close to it if you look through the extensions, but we're looking into that in time. Next, we're going to obtain some example Python code that exists in the GitHub repository and take a look at that and have a look at what that code is. We'll also take a look at some of the editing features that VS Code will provide you, including how VS Code manages your code folders as things called workspaces. We'll also look at how it can help identify issues with your code through highlighting them in the editor. These features are very simple but should not be underestimated. They can really speed up the process of writing code. One of the things I found when moving from just command line editors to IDEs like VS Code, I was using Nano for a while. I've used Notepad in my time, Notepad++. But the one thing I really noticed that was really useful from going to IDEs is when you do that, it can give you basically help as and when you're typing and writing code, which is incredibly helpful. And that saves you a tremendous amount of time over time. And it also helps to nudge you towards writing more readable code, as we'll see. We'll look at also how you can run code in VS Code, because obviously it wouldn't be much use if we couldn't do that, and also how we can use an often overlooked but incredibly useful feature known as debugging, right? Which is a really neat feature common to IDEs, allows you to specify in your code where you'd like your execution to pause. And then you can examine the state of your code at that point in mid-run, and then you can look for any issues. It's really handy. Okay, so without further ado, I'm now going to move over to a slightly different way of presenting. So here we go. I'm just going to make sure I've got my screen set up correctly. There's a lot of juggling of windows when doing something like this. So, right, just need to make sure this is, there we go. Okay, right. Great, great. So what we're going to do is we're going to start by running VS Code first on our own machines. So what I'd like you to do is to run it now. Now, you may have already run it before, of course, just to see if it's working, which is fine. But if you can run it again. So for me, I'm going to look in my applications. I'm going to find Visual Studio Code, and I'm going to click on that. And you should find you get a window that might look something like this. Now, over the various versions of Visual Studio Code, various various versions have presented themselves slightly differently to me on different platforms, and it does depend a lot on whether you've installed it previously or not. It may give you the option of changing the theme. It may give you an update of the features for this particular version. But more or less what you should find, he said, fingers crossed, is something that eventually looks like this. Okay. So what I'd like you to do is let's see, clear all feedback. So if you've managed to run Visual Studio Code and it's all looking reasonably like this, could you do a green tick box as a reaction? If you are not seeing this, do a red cross. That's absolutely fine, obviously. Oh, someone else in the chat's already said, like to add, there are super useful extensions in VSC. Indeed, there are. There are so many. I couldn't possibly begin to describe them all. Everything from managing Docker containers to web development, to running services, to remote debugging on various other servers. It's incredible, truly. And there are tens of thousands, possibly even hundreds of thousands, I don't know, of extensions. But we'll come to that in a moment. But that's a great point. Okay, all right. So it's looking like most people are there at the moment. Okay, so what we're going to do now is we're just going to do a quick tour of where we are. So let's see roughly what we are looking at. So we have a number of features which we're going to come to, but I'm just going to highlight their icons just so you can know your way around and how to basically navigate. So there's the Explorer, which is the top left one here, where you can hopefully see my mouse. This is a file navigator or explorer, a bit like a file browser. We can use this to open existing folders containing program files and navigate those files and view them. There's the search facility, which allows us to search over our code within a given folder. And that enables us to be able to find things or replace things to code, find and replace, which can be very useful. There's another icon here called source control, and this gives you access to effectively opening folders or opening code which is held in a code repository somewhere, such as on GitHub, which is really handy. The integration with Git is actually inherently one of the most useful things of Visual Studio Code I've found. And it means that you can clone repositories directly onto your machine from within VS Code without having to touch a command line, which is really useful sometimes. And it also can give you an idea of which files have changed over time as well as you're editing them within your checked out repository. There's also run and debug here. This allows you to run programs you write, and you can just run all the way through and just see what the output's going to be when you run it. And also it can enable you to run this code in special ways we'll see in a debugger. So we can check the state of our program as it's actually running, look at things like variables. And then finally, we have an icon here, which is to do with extensions. And we're going to look at this one in a moment. It allows you to install these much vaunted extensions to VS Code to extend its functionality in some way. Now, I should also point out that VS Code, when you first see it, it looks like it's an editor. You can do these things with it. It looks relatively straightforward, but that can be a little bit deceptive. There's an incredible amount of power that lies underneath Visual Studio Code, and there are many other features and many ways to access these features as well. And we're going to cover a couple of those as we go through. But the first thing we're going to do is we're going to install some extensions. Now, extensions, as I've said, are a major strength of VS Code. And it can present this interface that looks like a bit like an editor, and that's all it seems to be when you first start using it, as we'll see. But you can extend its functionality in many different ways. For example, we can install support for other languages, greater support for version control. There's even support for working with databases now and so on. There's tens of thousands. Now, VS Code already comes with built-in support for JavaScript, including TypeScript, Node.js, but also has some extensions for other languages like C++, C Sharp, Java, PHP, Go, many, many, many others. It's hard to keep track of them all, to be honest. Installing a language extension will allow you to do more things with that particular language in VS Code, as we'll see now. So let's start with doing that. So we're going to be playing with Python. So what would be nice would be to have some extensions perhaps that can help us with doing that. So what I'd like you to do is to click on the extensions icon just here. If you click on that, you should see a little box pop up that looks a bit like that. Okay. Then I'd like you to type in Python. Now you'll see a bewildering array of extensions here, but the one I'd like you to focus on is this one here, which is Python by Microsoft here. And you should see it's got like near 200 million downloads. So if you click on that and then click on install, now this might take a little while. You should see a sliding blue line sort of at the top, perhaps for a little while, until it's actually downloaded and installed it. I've already done this before to test it, so it didn't take me too long to download and install it because I'd already downloaded it. So I just want to check. So who successfully managed, I'm just going to clear the feedback, who successfully managed to install the Python extension? If you have, do a green tick boxes before and a red if you haven't been able to do that. Right, okay, so we're looking pretty good so far. Excellent stuff. Of course, if you do have any problems, feel free, please, to put any questions or problems you have in the chat, and either Alex or Aman will be able to get to that in time. If we have any time after the session, we can also do a Q&A and see if we can answer those questions then as well, of course. But yes, questions and problems in the chat. Right, okay, good stuff. So once complete, you should see it, perhaps this window. You should see that we now have this installed. You might well see this extension Python page come up, and you'll have disable, uninstall, or switch to another version there. So that basically indicates that we have this extension installed. Okay, so what we're going to do is we also need to configure this particular extension so that it knows where to find our Python installation. So once we've installed this extension, it doesn't yet know where to find Python. It's going to need that in order to be able to do things like run our code for us and be able to use some features of Python to do some reflection-based checking of our syntax. And so what we're going to do is we're going to use a feature in VS Code, which is incredibly powerful, called the command palette. And the command palette allows you to access basically all features that are available across VS Code, but not only VS Code, but also all the installed extensions as well. And what I'd like you to do is to run that command palette by going to, hang on a sec. Right, so if we go to, let's see, so in code, for me at least, on my Mac, the options for VS Code are on my bar here, right? If you go to view and then click on command palette, you should see that then pop up the command palette. If you're on Linux or Windows, you probably see these options present at the top of the bar here. Okay, so you should see file, edit, selection, and view, go, run, and terminal here. Okay, I'm just going to make that window a little bigger. Okay, but what I'd like you to do is click on view and then command palette. Okay, and you should see something like this pop up. What I'd like you to do next is to type Python select interpreter, and then hopefully you should see an option here just pop up here. Okay, I've already run this before, it's in my recently used, but hopefully you should see, just keep typing interpreter if you need it to, if you can't see it yet. But then if you click on select interpreter, then you should be able to then pick a version of Python to use. I'm going to pick 3.13.7. I could equally pick 3.9.6 in a number of different locations. If I wanted to, I'm going to pick the top one here. Okay. But pick the one that is the one that you've installed and you're happy to use. So once you've done that, if you could give me a green tick mark, that would be brilliant. If that's been a problem, we've run into an issue, please feel free to to put an X and let us know. Okay. So I can see. Okay. So if you have had a problem, feel free to put the error or the put the error message or a description of the problem into the chat, see what we can do. In case that went by a little quickly, what you can do is you can go to View, and then hopefully you'll find, so once you've selected the application VS Code, go to View and Command Palette. You may find those icons are sitting here as opposed to here if you're on Windows or Mac, Windows or Linux. Then type Python, select interpreter, like this, and then select that select interpreter option, and then select a version of Python like that. Okay. Right. If you're not seeing the option to select versions, I've seen this before. So is it that you're not seeing the list of Python versions to select from when you select Python select interpreter? Is that correct?
Yeah, that's correct. I like click on it and then I just get an empty screen.
Right, I see. Just to be clear then, so when you click on that, you're not seeing these options Python here, for example. Is that
No,
correct?
no, I'm not seeing them.
Ah, right. So I have seen this before. It's typically because there's there's a version of Python that I've installed that isn't being picked up by VS Code. One thing you could try that I have seen work is to run VS Code from the command line. So on most operating systems, when VS Code's installed, you could try code and then press return from a terminal prompt. What operating system are you using?
Windows.
Windows. Okay. So it could be. So do you know what version of Python you've installed?
No, it's okay. I will yeah, have another go and yeah, it's okay. Don't worry.
Okay. All
Yeah.
right. Good luck. Sorry I couldn't help you. But try doing a reinstallation of Python and making sure that Python is accessible from the command line. I usually find that that tends to work. So yeah, Alex has said, yeah, try install Python again. I usually find that's the trick. Okay. Good luck. I hope that that fixes it for you. Right. Okay. Right. So we've managed to get to this point here. Okay. Good stuff. So what we're going to do now is we're going to get hold of some sample code, right? And this sample code is what we're going to be using throughout the rest of this session. So I'm going to copy a link and put it into the chat, but you can also find it in the Google Doc as well that Alex shared at the start. Okay. Um, so actually, before we start, I'm going to ask a quick question, which is when you are running, when you've got with VS Code, if you click on the source control option, which is the third icon down, right? For those of you that see clone repository there, could you give me a green tick, please? So basically what VS Code allows us to do is to open code from a folder. But as we said earlier, it can also give you the ability to clone from a repository directly. If you don't see it, that's absolutely fine. So if you have Git already installed, it basically gives you another option to get hold of the code. We're going to go through both of them, so that's fine. So what I'd like you to do is to select, for those of you that do see that clone repository button there under source control, just click that. And what I'd like you to do is to copy and paste. Just need to find, perhaps, Aman, could you copy and paste the code repository URL into the chat if you have a second?
Yes, I'm just finding that. Sorry.
Excellent, no problem at all. Thank you, Aman. That looks good. So yeah, so if you copy that, and then, as I said, if you click on clone repository, put that in there like that. So you can just see that there, clone, select that, and then you select a location of where you want it to go. I'm just going to put it in my home directory, select as repository destination, and it goes away, and there we go. And it's gone away and cloned the repository, and I'm going to say open, right? And basically we get presented with this. So now what we've done is we've cloned that repository and we've opened that within VS Code, okay? So for those of you that do have actually managed to do that via clone repository, if you could do a green tick mark just to show that you've been able to do that. So it might take a while, I guess, depending on, okay. Okay, so you should see something that looks like this. And if you look in your home directory, you should see it cloned basically there, that directory there. So some of you have managed to do it, some of you haven't. Right, so for those of you that haven't been able to do that or haven't actually seen that clone repository option in source control, there's another way you can do that, and I'm going to show you that right now. So what I'm going to do is I'm going to close this. Okay, for those of you that have already done it and managed to do it that way, that's absolutely fine. Okay, just keep it open. But for those of you that haven't been able to do that, I'm just going to close that folder. I'm going to do it a different way. Okay, so I'm going to give you a link. All right, so this is a link to the release pages of that repository. So if you click on that, you should see something that looks like this. Okay, just over here. Can you see that? Right. Okay. So what I'd then advise you to do is to click on source code, zip, and then you should find it downloads it for you. Okay. Then using any method you like, then basically unzip that file in its download location. So I'm going to go to that location, and I'm going to just basically unzip that there like this. I could use so that's how I did it on Mac, by double clicking on the zip file. If you're under Linux, what you can do instead is you could do something like unzip code style example.zip. Or if you're on Windows, you can right click on it and do extract here. So for those of you that have then managed to do, when you've done that, if you give me a green tick just to show that you've managed to download and unzip that file. That might take a little while, so I'll give you a minute. Right. Okay, so I can see that's starting to happen. Okay, so once you've done that, if you then go to in VS Code, go to File, Open Folder, and then go to where you downloaded it. And I've got to try and find it. And select that folder that actually is the location of where you've unzipped it. Then click on Open. You should find you get something that looks a bit like this. Okay. Right. So what I'm going to do is do a quick check. So for everybody now who's managed to either clone the repository or download it, who's been able to open it in VS Code and see something that looks a bit like this. So if you have a problem, please feel free to put it in the chat, and Aman or Alex will be able to help you out there. Right. Okay. So, right, you may be presented with a window that asks you whether you trust the authors of the code. That's an important one. In general, it's good to be a little wary of cloning code on your machine, and VS Code forces you to think about that. So since you're obtaining code for the internet, so it's good to be a good idea to check your sources. So be careful here. I found on Windows, sometimes the trust option appears on the left, whilst on Mac it can appear on the right, just to confuse you. So in this case, feel free to trust the repository. Then you'll see the Explorer present you with some files in this small window. So you may see that pop up there. Okay, so feel free to select trust. So far with the VS Code, we've downloaded some code from the repository and opened a folder. Whenever we open a folder in VS Code, this is referred to as a workspace. So essentially, this is a collection of project files and directories, and within this workspace, you're going to see the following. So we have this data folder, which contains a single data file. We can click on that and have a look at it if we wish to do so. Okay. And you'll see that it basically contains a single comment line, which contains some information about the data in terms of what the type of the data is for each of the different elements. Then you'll see the data itself. in comma separated value form. Okay, so this is basically a simple table of data. Okay, in this case to do with rainfall. Okay, at various locations. We're going to have a look at that in a minute. There's also two other files, which is one of which is our climate analysis.python file, which is going to do the processing for us, and also our license.md file. Okay. Right, so let's have a look at what the code actually does. Now, the code that we're actually looking at is something that does some very, very simple. If we click on that file, we can see here there's our code presented. And this code actually is going to go through that data file that we saw line by line. And it's going to take one of the fields in one of the columns, right, on each line and convert that from Fahrenheit to Celsius and Fahrenheit to Kelvin, and then just print that to the screen. Okay. So I should point out that the code is deliberately written to have flaws. So things like, you'll notice that things like line spacing is inconsistent. There's no code comments. There's a variable that's not used. You may even spot other issues as well. But in essence, the code is designed to do this, to do the following. And we'll go into that in a little detail. So we have a few constants that are being defined here. We're also down here defining some functions that we're going to use to do this conversion. And then for each line in this climate data file that we've opened, we're going to go through each of those lines. And if it doesn't start with a comment line, which is a line that starts with a hash, it's going to do this temperature conversion on field number 3, okay? And then print those out to the terminal. So let's take a look at some of what the code editor gives us. So you may remember Alex talking about syntax highlighting. You'll notice that the Python syntax is being highlighted for us, which helps readability. So here you can see that it uses color to distinguish the various parts of our program. You'll notice that functions are yellow, Python statements are purple, variables are light blue, strings are this reddy orange sort of color here, and so on, which perhaps unsurprisingly is a feature known as syntax highlighting. And it's possible to edit the color scheme if you don't like it in particularly, to change it for various languages, depending on what kind of style you'd like to see. So this is really handy for giving us immediate feedback. It helps cognition, understanding code, and also if we do something incorrect, like we type something in like that, we can see now that the editor has sprung into life and started to say all kinds of things are wrong. So it gives us an at-a-glance way of determining whether our code is syntactically correct, okay, which is really handy. So if, for example, here's another example, if we remove the parenthesis, the closing parenthesis on this climate data equals open file line, we close that, we can see that there's got this red squiggly here and a red bracket, and if we hover over that, it says that it was not closed. Okay, this function wasn't closed. So that's giving us an idea automatically there's a problem with our code, and we can just correct that again. So the other thing that's really handy is its ability to do this thing, which is called code completion, which is something that Alex mentioned earlier. So it can actually help you write and format your code whilst you're typing. Okay, so for example, in a blank line somewhere, you can enter something like, I don't know, for X in something, right? Which is a way of iterating around something in a collection, which is in this case called something. Okay, now if we do that, we press the enter, you'll notice it indents for you, which is Python's way of showing a code block that's part of another code block. And we can see it's done this automatically, which is really kind of handy. So we're inside this loop. Now, another really helpful feature is something known as, which is code completion, which is in VS Code Talk is known as IntelliSense, right? But basically it's code completion. This is a really great time saver. It's a really useful feature for IDEs. So essentially, as you're typing, it works out the context of what it is you're attempting to do and tries to give you hints to do it. Now, it sounds annoying, but most of the time I find it really does help. And it also makes typing some long things in a lot quicker, as we'll see. So if we start typing a variable we've already defined, for example, climate underscore data, which we defined earlier on in the program, you will notice as we're typing it, that it kind of already knows that there's this thing called climate data. And if we press tab whilst we're in the middle of typing that, it completes this for us, hence code completion, right? So as we're zeroing in on completing a variable or a function, we can just use tab in the middle of typing it just to quickly fill that in. So that can really help save us some time. Another one is something like this. Another feature which I find particularly useful is so I'm going to ask a quick question. Who here's used a library of any shape or description in any language anywhere. If you have, if you throw up a green tick or a thumbs up or something, yeah, yeah, a lot of people. Okay, that's not too surprising, I suppose. Here's a question: who's typed one in and then had to basically look up typed in a function or something from a library you want to use, and then you've had to look up immediately what the parameters are for that particular function because you can't quite remember what they are. I'm going to put my hand up twice for this one because some features of languages are just you're using a library and there's like, I don't know, 50, 100 different functions you tend to use. It's very difficult to remember them all. Well, IDEs are really handy that way. So, for example, here's a basic example. If we're going to use, I don't know, open a new file, we can type open parenthesis, and now it's interrogated the Python language, and it happens to know what the open function is and what it does, and what kinds of parameters it takes, and we can use that as a means to work out what those are. And that can really save a tremendous amount of time as opposed to having to look at something online like an API documentation or something like that when we're writing our code to use a particular function. So using this code completion and this functional lookup can save us a lot of time. It's really useful. So, and as you've said, one really cool thing is you need a thing, install an extension. So with VS Code, one thing that's really great is ease with which we can add these new extensions when we need them. And this is true for many other IDEs as well. So, for example, if we want to write good Python code, we should be adding code comments, including doc strings for our functions, methods, and modules. So who here's ever done anything with doc strings in Python? Ever written a doc string, anybody, or seen one perhaps? Perhaps a few of you. So, okay, so doc strings are really handy. They're basically a formatted, templated way of describing what a function does, what inputs it takes, what outputs it takes, and not only for functions, also for classes, methods, properties, modules, and many other instances. So what we can do is we can do that, and commenting our code is a really good idea. All right, so let's try that now. So we're going to add an extension that's going to help us with writing doc strings. So what I'd like you to do is to click on the extensions icon again, and this time we're going to use an extension called auto docstring. Right, so if you type in auto docstring, one word, don't think the case particularly matters, and you should see one at the top by Niels Werner, or perhaps further down the list. I guess it might depend. I've installed it already, so perhaps it's put it at the top of the list. If you click on auto docstring, I've already got mine installed, as it turns out, but if you haven't got it installed, actually, I'll just uninstall it completely, and then just click install. There we go. Very quick process to uninstall and reinstall. You should then have auto docstring installed. Okay, so let's see how that's going to help us. So for those of you who've managed to do that, if you could do a quick green tick box, that would be brilliant. So I know it can be a bit annoying to do this all the time, but this is really handy for us to know where you are, whether we need to wait a little bit longer. Okay, great. So, right, so once you've done that, we can now make use of that feature, that extension, by first typing in 3 double quotes, and you should see it comes up with a pop-up in our code called generate docstring. If you press tab on that, you should see it comes up with a template for a docstring, right? Which is a way of just commenting this function, all right? Okay, so what I'm going to do is I'm going to type this in. I'm going to fill it in. I'm going to say you can type anything you like. You don't necessarily have to type exactly what I'm typing here, but just to illustrate what we can do with these. And using doc strings is a really good, well-established practice for commenting our code, and using things like auto doc strings just makes it that little bit quicker. So what we're doing is we're saying what it does, what the argument is, in this case only one argument, and what it returns. And it returns also what is effectively an integer. And I'm going to say temperature, in Celsius. Perhaps your doc strings are better than mine. I'll just quickly put that in. But it gives you an idea. So if you're in the habit of writing doc strings, using tools like auto docstring, like an extension like that, can really help us do that quickly. Okay, so very quick check. Who's managed to write a docstring? Could be anything you like. Perhaps you're still typing it out. But if you just give us an idea with a green tick box. Okay. Good, good. Right. Okay. So many of the features that we've covered are typical of many IDEs, right? And the great thing is they're really helpful at saving us time, right? So things like syntax highlighting, code completion, automatic code formatting, doing things like inserting doc strings automatically. It may not seem like much, but all those little time savers really do add up. And in the long run, could be saving us a tremendous amount of time, particularly if they're highlighting errors that may not be particularly obvious to us, that we end up finding further down the line. Right. So what we're going to do now is we're going to run our code in VS Code. So what we're going to do is I'm going to go back to the File Explorer now. So if I click on the File Explorer icon there, just go back to that because that's a nice place to be. Then what I'd like you to do is to click on the play icon in the top right there. Okay. So if you click on that, you should find you get something that looks a bit like this. Okay. And so what that's done is it's basically run our program. And you can see that it's used this command line command to actually run that code. And it's basically picked up the data file that we have in our data directory, gone through it line by line, done these temperature conversions as per what's in the code, and it's basically shown them in those conversions in Celsius and Kelvin. Okay, so hopefully you've been able to see that. So if you've been able to see that, if you just throw up a green tick box there, just see who's managed to do that. If you have not, please let us know if there's a problem. Okay, great. So, okay, if you haven't been able to do that, obviously, yeah, just let us know if there's a problem. So the pop-up window that we saw at the bottom there is not just showing us output. It's something that's known as a console or a terminal. And basically that's essentially our command prompt, right? Where the program is effectively run. And as I said, it's showing you the command it's using to run it and then putting that command into the terminal and running it. Now you'll notice the directory where the console runs is the current VS Code's project's workspace location. So in this case, with the terminal that I have on a Mac, I can do pwd, press return, and I can see that I'm at this location. Okay, so it's running the code inside this workspace within this directory. Okay. Now the other really cool thing about terminals is we can just type in commands as and when we need to. So we have this open. We don't have to open another terminal. We can do things like, I don't know, ls or something just to show us what's in the directory. We can type in other commands depending on the prompt we have open. If you're on Windows, you might find that you have the PowerShell or the Windows command prompt running instead. I currently have Bash because I'm currently running on a Mac on which I've installed Bash. If you're running this on Ubuntu Linux, you'll probably see the Bash shell there, for example. So it depends on the machine as to which prompt you'll actually get. But it does mean that we can access that prompt. So after the thing has completed, we could do all kinds of things like checking the output files if any were generated, other things. Okay, anything we wanted. Great. So what we're going to do now is we're going to move on to debugging code. Okay, so this is a feature which I think in IDEs is typically overlooked. And to be honest, when I first started coding, I hardly ever used debuggers. I tend to use them a lot more now. So one of the typical ways of debugging code is to add in print statements. And this is something I think that's common practice. So who here's added in print statements to their code to show that it's outputting things in the right way? Alex is waving her hand frantically. So am I. This is quite a normal, well-established practice. And that's fine, right? At a certain point in your code, you need to know what the state of things are, the state of play is, so you output contents of variables, and that's fine, that's good, right? And the great thing with that is you can identify a particular point in the code within perhaps the tail end of a function or within, I don't know, higher up in your code, wherever you want to display that and just put a print statement in or whatever and just output that, and that's fine. But there's an alternative to doing that, which is to really get to know the code from the inside out whilst it's actually running. And I tend to liken doing debugging a bit like performing exploratory surgery on a patient, right? You know there's something wrong, but you don't know exactly where the problem is. So what's useful with debuggers is you go looking within the code base as it's running to find the source of that problem. And it enables you to pause the code at various points that you specify to be able to do this kind of exploratory surgery, right? And in order to run a debugging session, we first need to tell the IDE where we'd like to examine the code. And then you can run the code in a special way using this debugger, right? And it pauses that execution at that breakpoint. And that's what we call these points in our code. We want the code to stop executing a breakpoint. And then you have this freedom to look around. Now, many people, when starting out with coding, disregard debuggers as complicated and tough to understand. And 30 or 40 years ago, that was certainly the case, okay? Particularly with natively compiled languages, okay? And they were indeed quite tricky to set up and use, and they've been avoided. But these days, particularly with these high level just-in-time compiled languages and interpreted languages, they're usually a lot more straightforward to use, and IDEs doing a lot of the complex stuff behind the scenes for us. So let's take a look at debugging by first of all introducing a problem, right? And then we're going to see if we can find that problem in our code using debugging. So let's assume we have a problem by introducing a problem. In our climate analysis code, I'm just going to close this terminal output. So in our climate analysis code, where it says if data 00 is not equal to comment, replace comment, right? The word comment there with single quote, exclamation mark, close quote. Now what we're doing there is effectively changing what we specify as a comment to be an exclamation mark, right? So the code as it usually runs is it looks to see if there's a hash symbol at the start of the line. If there is, it ignores it because it thinks it's a comment. We've changed that to be an exclamation mark. Now, perhaps we might assume one of our colleagues has erroneously made this change, but we haven't spotted it yet. So we tried to run the code as before, and if we just do that now, we can find it doesn't work, okay? And we can see here that it's telling us that there is a problem. It could not convert the string to float, max temp dual F. Now, what's going on here? Perhaps we cry. But let's just check to see, has everyone been able to get that value error after making that change? You should see this value error exception appear in the terminal. Yeah, okay. Right, I think that's generally the case. Good. So Aman, I see you have a hand raised.
I think there was just another hand raised. I was cross-checking if their problem is solved. If not, please feel free to speak up or type in the chat.
Thank you, Aman. I do apologize if I've missed it. I have a monitor full of various windows, and I do tend to miss things. I do apologize. But yes, if you do have a problem, feel free to raise your hand again. We can answer your question, or yeah, put it in the chat. Okay, right. So hopefully you've been able to see this value error exception there. So okay, so it's basically telling us it couldn't perform this conversion of a value extracted from the data file to a float, right? Which is what it's expecting to see, but it can't do that, and it's come up with this error. So what we're going to do now is we're going to add a debugging breakpoint, and then what we'll do is we use the debugger to step through our code until we find this error, and hopefully we can locate where that problem is. And I think we should all know where that problem is, but at least we can pretend that we don't. So now we know where the error is occurring, but we don't know perhaps the source of the problem, okay? Which may be in the same place, but it may not be. So let's add in what's known as a breakpoint to our code. So this is where our debugger is going to stop and pause and wait for our input to decide what to do. And what we'll do is we're going to do that. I'm just going to get rid of this terminal output window. And I'm going to put it at the start of the line for line in climate data. And we basically add a breakpoint by going to the left of the numbers, the line numbers. Oops. And then you should see, if you hover over it, you should see a faded red dot. And if you click on that, it should then become a solid red dot. Fingers crossed. Okay, so if you've been able to do that, you can give us a green tick box. Of course, if you're following along but not actually doing the live coding, that's fine. Okay, right, good. Right, so if you manage to get to that point, we've now added our breakpoint. So what we can do now is we can run the code using the debugger. So what we can do is we can go over to the run and debug icon over here, click on that, and then what we do is select run and debug. Now, the first time it does this, you'll probably find, let's see, Yes, it's going to ask you to select a debug configuration, right? So it usually tells you which one it thinks is the right one to do, and in this case, Python file. Okay, so if you select Python file like this, then fingers crossed, right? You should see something that looks like this. Okay, right. So if you've managed to get to that point, if you could give us a green tick box, that would be really awesome. Thank you. Some people say they don't have Python file as an option. I'm just going to, so if you've got to that point, that's fine. Just stay there for a minute. I'm just going to run this again. Now, of course, it already remembers my change from last time. So I'm just going to bring up the command palette and see if I can, right. No, I can't seem to access it. Yeah, it looks like, so it looks like I can't set it again because I've already set it, unfortunately. They got it. Okay, that's good. Excellent. Right. Thank you for that. Thank you for that. Look at this. Look, you're all helping each other, Nathania. Thank you so much for that. That's great. You've got that working. Okay. So if you've got to this point, that's just brilliant. Okay. Right. So what we need to do now is we need to see what's going on. Okay. So what's happened is the running of the code has paused on the line we entered the breakpoint, and it's telling us that by basically illustrating the line at which it stopped. Okay. So we can see that's highlighted. Now, some new information is now being displayed in various panes on the left of the code editor, and that's definitely worth taking a look at. So in particular, you'll see that there's one called variables on the left. Here we can see a list of variables which are currently active and their current state at this point in the script's execution. So we can see here we have comment, shift, climate data, and that's a reference to our open data file that it's currently processing. Other than that, we don't have particularly many at the moment. Now we also have, these are local variables. So if we were in a function and decided to use a breakpoint within a function, it would show us the internal state of that function, the variables that were in scope, that were currently active within that function. But there's also global variables as well. Now, as it turns out, pretty much all of the variables we're using here, not all of them, but nearly all of them are global variables. So if we click on the globals here, we'll see that most of them are actually, yeah, they're just effectively pretty much the same as we have in our local variable set. But as I say, if we were within a function, it would show us variables specific to that function here in locals as well. Okay. Now, the other interesting thing is we have what's known as a call stack. And this is a record of the journey the script has taken in terms of the functions called to get to this position in the execution. So it shows us that we're at the top level of our script, which makes sense since our breakpoint is at the top level of the script and not within any function. So, for example, if it were within the far to Kelvin function, for example, we'd see that function would be added to the call stack. Okay. It also shows us a line number where execution is paused at this level of the stack as well. And that can be really useful just to check the path at which the code has been executing functions to get to this very point. And it could be that the route is wrong. Perhaps it's taken the wrong route to get to a various point in our code. And that would tell us something. Okay. Now, we can also see some new icons at the top, okay? And these are all to do with how we control the debugging process. So the first one we see here is, if you hover over that, it should say continue, which allows the script to keep running until the next breakpoint, if there is one. The next one beyond that allows us to step over or through the script one statement at a time, okay? So we can take it one step at a time, check the variables, the call stack, and see how things are changing as we go through the code. And then we have the next two, which basically allows us to choose to step into or out of a function call, which is interesting. So if we wanted to examine the inner workings of a function during this debug session, we can do that. If we got to, for example, the line down here, Celsius equals far to Celsius, we could then opt at that point to go into the function, right, and then see the debugging process from within that view, okay? Or we could step over it and just not worry about it. Perhaps we're not interested. So we have a choice there, okay? So what we're going to do is we're going to step through our code by selecting the second icon, which is this one here, okay, which is step over, and see what happens. Now, as we do so, we can see the variable state changing, okay? By looking in the variable section, we can see that the line variable contains the first line read from the data file, which we can see here, okay? And that's the comment line. On the next step, we've reached the if statement. So if we step again and then again, our program halts because it's run into the problem we saw before, okay? Because it tries to do this conversion and then it bombs out, right? But at least now we've been able to isolate exactly the line of where that's actually happened, right, in our code by going through this step by step and seeing the process by which we've come to this point, okay? Right, okay, so this tells us something useful. It tells us that the problem occurs in the first iteration of the loop. Okay, so this implies the problem might be with the first line of data being processed since the Python code is going through the data line by line. So now let's stop the debugger, okay, by selecting the red square icon, okay. Right, so if we rerun the debugger, we can go through the process again. And we can see something interesting when we get to the if statement, okay. So I'm just going to do this until we get to the if statement. So from the code, we know that the if statement is looking for an exclamation mark at the beginning of the line to indicate a comment. However, the data variable containing the line contains a hash, okay, instead. Therefore, in this case, the code is going to assume it's a data line and attempt to process it as such. And that's where that will then lead us to the exception we saw before. Okay, so this is telling us that's clearly wrong, okay? So now if we stop the debugger, we can now fix this problem, okay? So we select the red square again, and then what we do is we edit that line and then we put it back to comment. The hash symbol, which is defined earlier in the Python file, then save that file. And to save a file, you can do file save. On a Mac, it's the Mac key and S at the same time as a shortcut, or on a Windows or Linux machine, it's Control S, I think. Okay, so I'm just going to get rid of that breakpoint since we don't need it anymore, hopefully. And then what we can do is we can run the code and fingers crossed, it all runs again. Okay, so now we've solved our problem. So that's all good. Okay, now obviously this is a very straightforward, relatively simple piece of code, but with a much larger code base, debugging really starts to come into its own. The trick is to identify the best points to add breakpoints. Okay, so I just want to check who's managed to go through that more or less to the end there. If you have been able to get all the way to the end, if you show us a green tick, that would be really useful. Okay, so most of you, that's really good to hear. Okay, thank you. So typically, putting it in context, typically we'd use debugging when we've discovered a problem. So other techniques, as Alex said, such as testing, are another way of finding problems, but they only identify that there are problems, but not always the root cause and location of the actual problem. So the great thing with debugging is it's the next step of that process. Sometimes we discover a problem, perhaps our code testing shows us there's an issue, perhaps we find out some other way, and if we're lucky, we can identify and fix the problem quickly. But where we can't, particularly with more complex programs, debugging is there to help us. So with particularly complex programs, it can be very difficult to reason about how they work, particularly at various points in the program with multiple functions, many different embedded, nested loops, and it can be very difficult to isolate where these issues are. So debugging helps us to pick apart that process step by step and help find the source of that issue. Any tips for identifying good breakpoints? Depends on the problem. That's a very good question. It does depend, okay, because I think when I've tended to pick good breakpoints, it's been prior to doing something that's a lot more complicated. So typically when you're writing a piece of code, it usually goes through a number of stages. And those stages might look, particularly in science, something like some level of data loading, initialization, some pre-processing to the data before you get to processing. And then you do the big processing thing, which is usually the most complex part of the program. And then you've got post-processing, which does something to the data coming out of that process to make it into a format that's suitable for exporting or saving or visualizing or something. I've usually found that the really good time to start doing that is just after you've done initial steps, such as you've done pre-processing. So once you've gone through a pre-processing step, just before you get to that really big processing step, that can be a good time to have a look at the data just to check that it's in the right state. Okay, and debugging can help there because that means you can just pause it at a breakpoint at that point, see what the data looks like before it goes into its massive processing step, which can be very difficult to navigate. The earlier in the process, the easier it is to generally find errors in your code. So yeah, putting them in at earlier points is generally a good idea, but it depends when the issue is occurring, of course. Sometimes if you've got an issue that's showing up at point Y further down there, that's where you'll probably start looking. Okay. But as you go through the diagnostic process, you might find yourself adding breakpoints earlier and earlier and earlier because the problem actually occurred much sooner. So it's kind of like I say, exploratory surgery. You have to start somewhere because it's not always clear where the problem is, and go and have a look and see if there's something wrong and try and trace it back by changing where you put those breakpoints. That makes sense. There's a question here. What if you're working on a Jupyter notebook for development prior to making script? Can a debugger help there too? That's a very good question. So Alex has answered, in Jupyter notebook, you can execute step by step anyway, so you can always check the value of variables. So that's kind of an inbuilt sort of debugger model in a sense, because effectively you're seeing the state, as the cells are getting computed computation by computation. And that's really handy, actually. That's one thing I really like about Jupyter notebooks. You control that process. So yeah, that's really helpful. Right, so I see we have 10 minutes. Does anyone have any other questions? So we've come to the end of the practical part of the activity. I hope that was useful to everybody. Has anyone got any other questions or anything really? Any points they'd like to raise? Feel free to put the questions in the chat or throw a hand up and we'll take questions. Yes, there will be a recording of this. Unfortunately, we started the recording a little bit late, but we did get most of it. So hopefully that'll be useful to you. Okay. Right. So I see we have 9 minutes. Do we want to, Alex? Yes, you have a hand.
Yes, just wanted to double check with Anna. I know she managed to resolve her problem, but she still didn't see, I think, an install button. So just wanted to offer to stay a little bit after
I
the
think I
session.
have solved it, but thank you.
Okay,
I'm not
and if
exactly sure what I've done, but I could do everything, so I think it was okay. Thank you.
okay, lovely. And if anyone else needs to maybe stay after and ask some questions, I'll be available.
Yeah, me too. I'll be around for 15 minutes at least. So.
There is another question in the chat about the debug console.
How does a debug console fit in? Oh, that's a good question. Now, I'm wondering if that's a feature I've actually used in this. So we have a look. All I'll do is so in this particular idea, I don't think I've ever used it before. So yes, that's a very good question. So the debug console, if I recall correctly, is, yeah, the debug console, a feature I should probably add to the materials. This is an excellent point. So when you've paused execution using a debugger, what you can do is you can actually execute commands. This is one of the features of interpreted or pseudo-interpreted languages like Python. You can basically run commands directly to explore even further what's going on with your code, which can be incredibly useful. So, for example, we could run functions here if we wanted to at this paused execution step, right? And that is an incredibly powerful feature, right? Typically, you don't usually find that in compiled languages, but interpreted languages, it's just another thing it's going to run. So you can basically do anything you want. We could do print. That's not particularly exciting, but we could do something like that, maybe. Yeah. We could do some arithmetic. We could call functions. We could do all kinds of things. So you can run commands at that breakpoint if we want. Yeah. Thank you for that question. Going to add that to the materials. Right. Yes. Alex has pasted in a feedback form for today. It would be incredibly useful if you could fill that in before you leave. It won't take very long. and it helps us to justify doing these kinds of events in the future. So yes, let us know what you think. Things you liked, things you perhaps might want to see, things perhaps that we didn't cover, but we couldn't because of time, and other ways perhaps you think we could improve it. But putting in the positives are just as useful as putting in the negatives, because we need to be able to see what's good before we change anything. We don't want to break things that you thought worked really well. Yes, a little example of debugging within a function. It is exactly the same, more or less exactly the same principle. So what we can do, I better stop first. So what we can do is, for example, we have this far to Kelvin function here, and we can basically put in a breakpoint at that location, for example, right? And this is just another point in the code. It doesn't really differentiate. You can put a breakpoint anywhere you like. And then when you do the run and debug, it'll pause within the execution of that function. Now, what you'll see here is that the call stack's changed. It's slightly different. We have our higher level, top level part of our code here, climate analysis.py, and that's called far to Kelvin function here. And that call stack is telling us that that's where we are. Okay, so it's gone all the way down to here, and then executed this function, and it's paused at this point here, right? And we can check that the variables in this function. Now we only have one, which is far. That's fine. But here we can also access our global variables as well, which is what's in the main program. In effect, okay, they're still kind of accessible here. Obviously, we shouldn't really be accessing global variables from within a function, but there they are all the same. So it's more or less the same process. It just gives you the added context of what's going on locally within the function as well. I hope that answers your question. Oh, yes, and Alex made a very good point. You can put as many breakpoints in as you want to pause the execution of the code in multiple locations. So we could have one within far to Kelvin. We could have one, as we saw before, I don't know, perhaps we put it here. So I'm going to put a breakpoint there, stop this, and then rerun it. You'll notice the first time it goes through this, right? It won't stop here because it hasn't been called yet, even though it occurs earlier in the program. When it reaches the first breakpoint in the program's lifecycle, which is here, stops here. Now, if we continue execution, it should find, yes, now, okay, it's gone round, and of course, the first one to comment, so it's ignored doing the computation the first time, but the second time, it does call that function, okay? And at that point, it stops here. So we can add as many breakpoints as we want to have a look at the code in a single run at different points. Okay. These are all really good points. We're going to see if we can work these into future versions of this. How about debugging a GUI with this? I have the code, the GUI would open and never managed to get to the breakpoint error. Depends, I guess, on the code. How would you debug a GUI? I guess the same principles, I guess, would apply. It does depend on how the individual functions within your Python script are being called from within your GUI as well. And I do know there are some instances of ways in which code is executed that could stop, that can actually stop how a debugger should operate. I don't know if that's the culprit here, but yes, I guess it depends entirely on the code there in that case. But yes, it is possible to do that. But as Alex said, it could be the error happens before your breakpoint. Step over versus step into, yes. So when you're doing a step over, what that does is if you come to, say, a function call in your script, so for example, we have Celsius is equal to far to Celsius. If we do a step over, what that means is it will not go into far to Celsius, right? The debugger won't go into that and show us line by line what's happening with that function, okay? Step over will basically just execute that function, come back to this point and continue to the next line here, okay? If we do step into, that means we do want to see what's going on inside the function's execution. So that will then step into far to Celsius and show us the debugger going through running that. So actually I can quickly demonstrate that. So if I put a breakpoint there, run it again in debug mode, like this. Okay, so now we have the option to step over or step into. Let's step into. And here you can see we've now gone into that function, and we can do the same thing as before. Go back to this process of deciding whether you want to step into or step over. In this case, we can only step over. Really, don't think we can step into that. The other thing you'll notice really handy is telling us the value of variables here at the end of the line as it goes in, so we can verify that by eye to see if it roughly looks right. So we can continue and then come out. Right, now this time we'll do a step over, and we don't execute, we don't show the inner workings of far2Celsius. The debugger doesn't go into that function and show its execution. Okay, so we have a lot of control about how that process works. Depends what we want to see, what's interesting to us. Okay, I hope that answered the question.
There is another one, Steve, about launch.json file.
Oh, yes. Okay. So when do you need to do that? So it depends. So by default, it depends on it depends a lot on the environment that you have. So VS Code gives you a tremendous amount of power to change the process by which it does things like debugging. Okay. So with launch.json, you can effectively tell it what commands to run when you want to do things like debugging and how to do it. So I don't know, perhaps, and this is something I haven't done, but if you've got a particular code profiler or debugger that you want to use, you could, for example, set that up by changing launch.json to use that program instead of the inbuilt one that we've got here, for example. That's a little bit, well, it's quite far beyond the scope of the session, unfortunately. But yes, effectively, you have the power to change how it does debugging and pretty much anything. So yeah, you can do that if you want. So actually, yeah. So if I can find a good link there that might help. Okay, here's from the official documentation. And I think that tells you a little bit about how to do, yeah, that tells you the basics. I think it also covers, yeah, that's covering pretty much what we've covered already. There it is. That's the one I'm looking for. This one. So disregard that one. This is the one you want. So yeah, you can basically set up a debug configuration by adding in a launch.json file or changing your existing one. Okay, I hope that's useful. Right. Yes. Please fill in the feedback. I only take a couple of minutes. Really useful for us. Yes, I'd like to thank you all. You've been absolutely a delight to teach, and it's been good to see that you've been able to keep, most of you at least, have been able to keep up. And I hope it didn't go too fast for those that weren't able to do it. But nevertheless, I hope it's still been a useful session. Some very good questions too.
Thanks very much, everyone. Thanks to Steve and to Aman, which brings us to the end of this session.